Here is an example based on the ideal transformer with the transformer ratio. Okay, so the transformer ratio he gave us as 1:2 right there. Okay, and V1, V2 are given and there are dots right there. So in this kind of circuits, first thing we need to do is convert the time domain circuit into frequency domain. Here the given circuit is already in frequency domain. We don't need to do anything. Keep it as it is. Now assign the loop current. So I'm going to assign, here is my loop 1. I'm going to take this as I1, and loop 2 my I2, and loop 3 I3. Okay, this is my I3. Sometimes you might not have this wire right there, but that's okay. We can connect this wire because the reason behind it is these two on primary side of the coil and secondary side of the coil, we're going to ground it. So ground voltage is 0. So one wire of the transformer, primary side and secondary side, both sides is going to be 0 voltage. So that is the reason we can connect these two wires. Still, there won't be any difference in the circuit. Now, loop 1, apply KVL. So according to my current direction, that's minus 12 at an angle of 0, plus the current passing through this is I1, plus and minus, so plus 4 I1 plus V1. That's my first equation. Okay, now loop 2, apply KVL. So according to my loop 2 direction, I'm starting from here, plus and minus, plus 8 I2. I'm entering the negative terminal, so minus V2, plus 2 I2 minus I3. So it is 10 I2 minus 2 I3 minus V2 equal to 0. That's my second equation. Now loop 3, apply KVL in loop 3 equation. According to my loop 3, here 8 I3 plus 2 times I3 minus I2 plus V2 minus V1. So 2 I3 minus I2 plus V2. So current is entering the dot. So plus, the current is going towards down, entering the positive there. So plus V2 minus V1 equal to 0. That's my third equation. Okay, so third equation is minus 2 I2 plus 10 I3 plus V2 minus V1 equal to 0. Now the next equation we're going to do is a transformer ratio. So based on the current direction, based on the transformer ratio, we know that V2 over V1 equal to N2 over N1. Okay, now because of the dots, we need to find out whether that is negative or positive. This transformer ratio is positive or negative. That's what we need to find. So if you look at here, the current going down, what is the current going down there? It must be I1 minus I3. That I1 minus I3 is entering the dot. So the dot terminal must be positive here. So this must be positive. This must be negative for V2. Okay, but the given, so V2 over V1 equal to N2 over N1. So I need to find whether it is negative or positive. So the current is entering the dot. The dotted terminal must be positive, but the given value, given V2 is negative. Both of them are on the opposite side, opposite sign. So definitely this V2 must be negative V2. Okay, so V2 over V1 equal to negative 2 over 1. I'm just moving the negative. So V2 equal to negative 2, 1. That's my equation 4. Now we have another equation. That another equation is based on the I1, based on the current ratio. How do you know there are 5 equations based on the number of unknowns? The number of unknowns, our main goal is finding V0. V0 equal to, all I need, find I3, 8 times I3. As long as I find I3, we're good to go. But to find I3, I have 5 unknowns in the equation. One is I1, I2, I3, V1 and V2. So that's the reason I have to come up with the 5th equation. So when it comes to the 5th equation, The fifth equation is based on the current ratios. Okay, so I already chose current I1 minus I3 is coming down, so I will stick to that current. I have to stick to that current. I cannot change this current direction because when I'm writing the voltage equation, I used that current direction, so I have to stick to that. Now on the secondary side, it's up to you. You can choose the current direction, but I'm going to choose the current is going to down, current going down. So here this value must be I3 minus I2. I'm assuming I3 current is going down, I2 is going up, so that current must be I3 minus I2. So I1 minus I3 over I3 minus I2 equal to 2 over 1. Okay, now I need to find whether it is negative or positive. Now current is entering the dot. The dotted terminal must be positive, so this must be positive for the voltage, and the current must leave out of this dot. Current must go out of the dot. Is the current leaving the dot? Yes. So if that is the case, then this is positive. We are good to go. This is my fifth equation. So my fifth equation is I1 minus I3 over I3 minus I2 equal to 2. When I simplify this, it's going to be I1 minus I3 equal to 2I3 minus 2I2. Okay, so I1 minus or plus 2I2 minus 3I3 equal to 0. This is my fifth equation. Now I have 5 equations, 5 unknowns. All I need to find I3. So I will solve to find I3. I'm going to do fifth equation one more time. Say for example, I assume this current is going up. Okay, instead of going down, I'm assuming that current is going up. So I'm going to use the green. So what is the current going up here? It must be I2 minus I3. When the current is coming down, it must be I3 minus I2. When it's going up, it must be I2 minus I3. Current is a vector quantity, so it has both direction and magnitude. So when you change the direction, the sign is going to change. Okay, that's what happened. So basically what I'm saying, you can say 2 amperes flowing in this direction, or you can say minus 2 amperes flowing in the opposite direction. Both of them are saying the same thing. That's what I did here. Now according to my current direction, it must be I1 minus I3 over I2 minus I3, since I'm using I2 minus I3, equal to 2 over 1. Now I need to find whether it is positive or negative. Now current is entering the dot. The dotted terminal must be positive. It's right there, and the current supposed to leave this positive terminal. Okay, but current is entering there, so it's going to be negative. So if you look at here, these two are saying the same thing. So it doesn't matter your secondary current, which direction you take, you will end up with the same equations. Now I'm going to solve all these 5 equations to find I3. To simplify these equations, step 1, I'm going to substitute equation 4 in equation 3, so that way I can eliminate either V2 or V1. So I substituted equation 3 in equation 4. So equation 4 says V2 equal to minus 2V1. So I substituted V2 equal to minus 2V1. Okay, I end up with minus 2I2 plus 10I3 minus 3V1 equal to 0. Now I'm going to play with equation 6 and equation 1 to eliminate V1. So equation 1, I have 12 at an angle of 0 plus 4I1 plus V1 equal to 0. What I'm going to do, I'm going to multiply equation 1 with the 3. This is my equation 1. So minus 36, so I'm going to put it on the other side. 12I1 plus 3V1 equal to 36 at an angle of 0. This is, I'm going to say, equation 7. All I did, multiply equation 1 with the 3. So all I did, multiplied equation 1 with the number 3. So 12I1 plus 3V1 equal 36 at an angle of 0. I have minus 2i2 plus 10i3 minus 3v1 equal to 0. Now I'm going to add these two equations. So v1 get cancelled out. So 12i1 minus 2i2 plus 10i3 equal to 36 at an angle of 0. This is my equation 8. Now I'm going to play with equation 8 and equation 5. Our main goal is finding i3, so it's up to you. We can eliminate either i1 or i3. So if you look at equation 5, I have i1 plus 2i2 minus 3i3 equal to 0. This is my equation 5. I'm going to add these two equations to eliminate i2. So I have 13i1 plus 7i3 equal to 36 at an angle of 0. Now I have relation between i1 and i3. So I need to make another equation in terms of i1 and i3. Now I have one equation with the relation between i1 and i3. If I can get another equation with the relation between i1 and i3, I can find i3. Now here I'm going to substitute equation 4 in equation 2, and then I'm going to play with equation 1 and 2. Again, the new equation, I'm going to play with the equation 5. Let me put it down. So substitute equation 4 in equation 2. So here is my equation 2, 10i2 minus 2i3 minus v2 equals 0 and v2 equal to minus 2v1. That's equation 4. I'm going to substitute v2 equal to minus 2v1. So this will be 10i2 minus 2i3 minus 2v1, minus of minus plus 2v1 equal to 0. This is my equation 9. Okay, now I'm going to substitute or subtract equation, or I'm going to play with equation 9 and equation 1. So 4i1 plus v1 equal to 12 at an angle of 0. That's my equation 1. I'm going to multiply this with 2. Okay, so it will be 8i1 plus 2v1 equal to 24 at an angle of 0. I'm going to label this as 10. Now I'm going to play with the equation 9 and 10. So ninth equation, I have 10i2 minus 2i3 plus 2v1 equal to 0. I'm going to subtract this. So I'll end up with 8i1 minus 10i2 plus 2i3. When I'm subtracting, those two get cancelled out. 24 at an angle of 0. This is my 11th equation. Now to eliminate i2, I'm going to play with the equation 11 and equation 3. Equation 5. Equation 5, I have i1 plus 2i2 minus 3i3. i1 plus 2i2 minus 3i3 equal to 0. This is my equation 5. I'm going to multiply this with 5. So it's going to be 5i1 plus 10i2 minus 15i3 equal to 0. Above equation, this is, I'm going to label this as equation 12. Above equation, I have 8i1 minus 10i2 plus 2i3 equal to 24 at an angle of 0. This is equation 11. Now I'm going to add these two equations. I will end up with 13i1, cancel out these two, minus 13i3 equal to 24 at an angle of 0. This is my 13th equation. Okay, so 13th equation has coefficient of 13. That's good. Okay, now I have another equation with relation between i1 and i3. I think I forgot to label that. Let me label this equation as, I believe we didn't use 6 anywhere, or 7, 6, 7, 8, 9. I forgot to label this, so that's okay. That's the equation I'm going to use. So I have 13i1 plus 7i3. 13i1 plus 7i3 equal to 36 at an angle of 0. Okay, now what I'm going to do, I'm going to subtract these two. I1 get cancelled out, minus 20i3 equal to, so minus 12 at an angle of 0. So I3 must be 12 over 20. That value is 0.6 ampere. Once you have I3, your V naught equal to I3 times 8 ohm. Okay, so 0.6 times 8, 4.8 volt. That's the voltage drop across the 8 ohm resistor. Okay, it's a lengthy video, but please go through it to understand all the steps. I will give more value to these 5 equations. So 1, 2, 3, 4 and 5. Okay, if I ask you this question for 50 points, probably I will assign at least 40 above points for these 5 equations. If you mess up somewhere, like instead of plus here, if you put minus, or instead of minus you put plus there, I will take off 5 points. So if you mess up 2 places, one there, another one here, that's minus 10 points. So pay more attention to write these equations. Okay, thank you. I'll make another video with a similar example, and then I'll move on to the auto transformers. Thank you.